Next IEEE standard is 802.4 token bus. Okay, we will discuss about token bus. In the previous class, we have discussed about IEEE 802.3, which is Ethernet, and we have discussed the frame format of IEEE 802.3. Now we are going to discuss IEEE 802.4, which is token bus. Okay, we will see what is a token bus and how a frame is transmitted in token bus and what is the frame format of token bus. Okay, now we will see what is a token bus. So token bus is actually a linear or a tree shaped cable. So token bus is nothing but is a linear or tree shaped cable, or is simply a linear cable onto which stations are attached. So physically it is a linear cable into which stations are attached, but logically stations are organized into a ring. So logically token bus is organized into a ring, but physically it is a linear cable. Logically, stations are organized into a ring, with each station knowing the address of the station to its left and right. So each station knows the address of its neighbors. Means address. So the logically this token bus is organized into a ring. So in a ring, a station can have a left neighbor and a right neighbor, and each station knows the address of the left station and the right station. Because it is a ring, each station must have a left neighbor and a right neighbor, and each station knows its left neighbor and right neighbor. Okay, so physically it's a ring, physically it is a linear shaped cable, and logically it is a ring. When the logical ring is initialized, the highest numbered station may send the first frame and will pass permission to its immediate neighbor by sending a special control frame called token. So in token bus, if a station wants to transmit a frame, that station must acquire a special control frame called a token. So a machine that have a token can only transmit data. If a station have to send a data but it has not a token, then the station cannot transmit and it has to wait until it can capture a token in the network. So a station with a token can only transmit data. That's why we can avoid collision in token bus, because only one station can transmit the frame at a time, because that machine have the token. No other machine in the network have the token. Okay. When the logical ring is initialized, the highest numbered station means the station with the highest address may send the first frame. So who can send the first frame? The machine with the highest address can send the first frame, and after that sending is over, the highest numbered station will pass the permission, or will pass the token to its immediate neighbor, which means will pass the permission to the machine which have next highest address. So when the ring is initialized, stations are inserted into it in the order of stations addresses, station address from highest to lowest. So when the ring is initialized, stations are inserted into it in the order of address. Means the station with the highest address is inserted into the ring first, and the machine with the next lowest address is inserted into this ring next, and the machine with the lowest address is inserted at last. Physical order of stations does not matter, because transmission works in the order of addresses, so physical order is not important, and the transmission line is not a broadcast medium. Send token by addressing the neighbors, and provision for addressing deleting stations. So in token bus there are provisions for adding stations and deleting stations. Physical error is not at all compatible with IEEE802.3, a very complicated standard. So this is generally what a token bus is. So you can see in this figure, what a token bus is. So you can see in this token bus, this is a token bus. You can see physically all machines are connected to a linear cable. Station 1, station 2, station 3, 4 and 5 are connected to, this is a linear cable. It's a transmission line to which all the machines are connected, and but a transmission takes place in the form of a ring, which means logically these machines are connected to a ring. Okay, this indicates a logical ring, and the ring is created in the basis of machine address. The machine with highest address is inserted in the ring first, and the machine with the next highest address will be inserted second, and the machine with the lowest address will be inserted at the last, and token will be passed in this direction, and communication takes only in this direction. So this is a token bus, and now we understand. Now we can understand what a token bus is, and now we will see what is the frame structure of token bus. Okay, this is a token bus frame format. So in this data link layer, data will be transmitted in the form of frames. We have already seen that, and here the frame contains different fields. The first field is a preamble field, as in 802.3 you can see the first field as preamble, the second field is start delimiter, and the third field is frame control, destination address, source address, data, checksum and end delimiter. So preamble, as in 802.3, preamble is used for synchronization. We have discussed this preamble field in 802.3. So preamble is used for synchronization, and there is a starting delimiter and ending delimiter. So this the size of these fields are given in bytes. Preamble is 1 byte and starting delimiter is 1 byte. So frame control field is also 1 byte. Destination field can be 2 or 6 bytes. Source address can be 2 or 6, and data can be up to 8182 bytes, and checksum is a 4 byte. Okay, the second field is delimiter, and the last field ending delimiter. So starting delimiter and ending delimiter fields are used to mark frame boundaries. Starting delimiter mark the starting of the frame boundary, and the ending delimiter mark the ending of the frame. So these two delimiters mark the starting and ending of a frame. Frame control field. Next is a frame control field. Frame control field is used to distinguish data frames from control frames. So we can have data frames and we can have control frames also. Example of control frame is an acknowledgement frame. Acknowledgement frame normally does not contain data. So we have to distinguish between a data frame and an acknowledgement frames or control frames. A control frames can be an acknowledgement frame. It can be various types, and we will discuss the various types of control frames later. So frame control field is used to distinguish between data frames and control frames. For data frames, if this is a data frame, which means this field contains data, then it will be a data frame. If it is a data frame, what would be the control frame? What would be the frame control field? If it is a data frame, what will be the frame control field? If it is a data frame, it carries a frame priority. So if it is a data frame, this frame control field will specify the priority of this frame. Okay, it can carry, this frame control field can carry a priority of this frame if it's a data frame, or it can carry an indicator to the destination to send an acknowledgement. Frame control field can contain an indicator to the destination to send an acknowledgement, which means the frame control field can carry an indicator to the destination to send an acknowledgement, which means suppose a machine is sending a frame to its destination, because if suppose there is a station and that station has the token, and then the station can send the frame to the destination, but the destination cannot send acknowledgement because the destination do not have the token. ഇപ്പോൾ ടോക്കൺ ഉണ്ടെങ്കിൽ ഡേറ്റ ട്രാൻസ്മിറ്റ് ചെയ്യാൻ പറ്റും. ഡേറ്റ ആണെങ്കിലും അക്നോളജ്മെന്റ് ആണെങ്കിലും എന്താണെങ്കിലും ഒരു സ്റ്റേഷന് ട്രാൻസ്മിറ്റ് ചെയ്യണമെങ്കിൽ ആ സ്റ്റേഷന് ടോക്കൺ വേണം. ഓക്കെ, ഇപ്പോൾ ടോക്കൺ ഉള്ളത് കൊണ്ട് ഡേറ്റ ട്രാൻസ്മിറ്റ് ചെയ്തു, പക്ഷേ ടോക്കൺ ഇല്ലാത്തത് കൊണ്ട് അക്നോളജ്മെന്റ് സെൻഡ് ചെയ്യാൻ പറ്റില്ല. അപ്പോൾ ഇതിനകത്ത് നമുക്ക് ഈ ഫ്രെയിം കൺട്രോൾ ഫീൽഡ് തന്നെ സ്പെസിഫൈ ചെയ്യാം. എന്താണ് ദിസ് ഫ്രെയിം കൺട്രോൾ ഫീൽഡ്? വി ക്യാൻ യൂസ് ദിസ് ഫീൽഡ്. We can use this field to send the destination, or to we can use this field to tell the destination to send an acknowledgement back. ഇവിടെ നിങ്ങളൊരു you can put an indicator here to tell the destination എടുത്ത് പറയാം, നിങ്ങൾ അക്നോളജ്മെന്റ് അയച്ചു, ഒരു ടോക്കൺ ഇല്ലെങ്കിലും you can send the acknowledgement. അങ്ങനെ ഒരു ഇൻഡിക്കേറ്റർ നമുക്കിവിടെ ഈ ഫ്രെയിം കൺട്രോൾ ഫീൽഡിൽ പറയാം. ഇത് രണ്ടും if it is a data frame ആണെങ്കിൽ. If it is a control frame, if this is a control frame, what will be the use of, or what will be the content of this frame control field? For control frames like acknowledgement frames, this frame control field can be used to specify the frame type. There are a number of control frames are there, and for control frames, frame control field can be used to specify the frame type. Different frame types include token passing and the various ring maintenance frames, including the mechanism for entering and leaving the ring. There are a number of control frames. Token is a control frame, and various ring maintenance frame are there, including frames. If a machine has to enter the frame, if a machine has to enter the ring, then the machine has to send a particular frame. And if a machine has to leave the frame, then also that machine has to send a frame. There are different frames, so they are all control frames, and different frame types indicate these different frames, and that frame type is included in this frame control field. Okay, data field, this destination address and source address we have already discussed as in 802.3. Destination address and source address can be 2 bytes or 6 bytes. This data field can be up to 8182 bytes. If we use a 2-byte addressing, destination address and source address can be 2 or 6 bytes. If you are using 2-byte address, then data field can be up to 8182 bytes with a 2-byte addressing, and 8174 bytes with 6. This is 6 bytes. If you are using 6-byte addressing, the data size can be up to 8174 bytes. Okay, so these are the different control frames in token bus. Claim token, this is a frame frame names, and this is a frame control field. These are the different control frames, and these are the uses of this control frame. So what are the control frames? Claim token, solicit successor 1, solicit successor 2, who follows, resolve contention, token, set successor. These are the different control frames in token bus, and these are the contents of the frame control field for corresponding control frames. Okay, these are the meaning. So When this claim token frame can be sent by a station. So this claim token frame is a control frame, and that frame can be sent by a station to claim token during ring initialization. So during ring initialization, a station can claim token by using claim token control frame. This is a frame that can be sent by a machine, sent by a station during ring initialization to claim token. Also, solicit successor 1, solicit successor 2, these are two control frames, and these two control frames allow station to enter the ring. If a machine has to enter a ring, then a machine can send either one of the solicit successor 1 or solicit successor 2 control frames, and who follows control frame can be used to recover from a lost token and resolve contention. This is also a control frame that can be used when multiple stations want to enter the frame or want to enter the ring. Okay, when multiple stations want to enter the ring, this resolve contention control frame can be used. Then token is the token control frame, and set successor allows a station to leave the ring. So if a station want to leave the ring, then that machine will set its successor in place of that station. Okay. അപ്പോൾ അത് ഒരു റിംഗ് മെയിൻ്റനൻസ് ആണ്, കുറച്ച് തിയറി ആയിട്ടുണ്ട്. അപ്പോൾ നിങ്ങളിത് ഇപ്പോൾ ഇത് പഠിക്കുക. നമുക്കത് വായിച്ച് നോക്കാം. ഓക്കെ. ഇപ്പോൾ ഇത്രയും കൺട്രോൾ ഫ്രെയിംസ് ഉണ്ടെന്ന് മനസ്സിലാക്കുക. ദീസ് ആർ ദ യൂസസ് ഓഫ് ദീസ് കൺട്രോൾ ഫ്രെയിംസ്. ഇതാണ് ടോക്കൺ ബേസിനെ പറ്റി ജനറലി പറയാനുള്ളത്. അപ്പോൾ എൻ്റെ ഫ്രെയിം സ്ട്രക്ചർ വളരെ ഇമ്പോർട്ടൻ്റ് ആണ്. പിന്നെ ഒന്ന് ഓർത്ത് വയ്ക്കുക, ചോദിക്കുകയാണെങ്കിൽ എഴുതാം. ഇതിൻ്റെ വളരെ ഡിസ്കഷനോട്ടൊന്നും പോകേണ്ട കാര്യമില്ല. ഓക്കെ.